Hi, everybody. This is Mr. Collins here to teach you a little bit about oceans. We're focusing on learning target 52. I can describe how oceans and ocean currents affect climate. Terms we're covering today: ocean current, climate, and density. First of all, what are oceans made of? Well, oceans have salt water in them, and the amount of saltiness in the water can change. We can have high salinity or high saltiness, and we can have low salinity or less saltiness. Where we tend to have high salinity is where the water molecules are leaving the ocean and leaving the salt behind. When water evaporates, salt gets left behind. And also when water freezes, salt will be left in the liquid water. Both of these conditions can make certain places of the ocean more salty or a higher salinity. Salinity tends to be lowest where the ocean is diluted by fresh water. Where we have more fresh water entering the ocean is where we will have low salinity. For example, where rivers carrying fresh water empty into the ocean, we will have low salinity or less saltiness. Locations that have a lot of precipitation or a lot of rain will also tend to have lower salinity. Now, salinity, again, is the amount of salt that is dissolved in water. As this salt dissolves in water, it fills in empty spaces in between the water molecules. So, in essence, we keep the same amount of volume, but we put more stuff in there. The blue is representing water molecules. Blue is water molecules. The yellow and the purple would be representing salt that is dissolving into the water. Same volume, but different masses. This is all about density. Density is the amount of matter in a given volume. This should remind you of first trimester when we spent some time with density and we had a formula for density. D equals M over V. Density equals mass divided by volume. More salinity, more density. Less salinity, less density. The higher salinity equals the higher density. Now, things that are more dense will sink. So that higher saline content or the high salinity, the extremely salty water tends to sink and the less salty water tends to float. This is one thing that causes waters in the oceans to flow around, to move around. Now, the major thing that is going to be causing ocean currents is going to be these changes in density. So, what is an ocean current? An ocean current is the mass of moving water. What we have found on planet Earth looking at our oceans, we have a major ocean current. If I start here in the Atlantic Ocean, travels on the surface. The red is representing on the surface where it is warmer. The blue is representing deep in the ocean where it is cooler. Tends to travel towards the north where it gets colder and sinks back down, becoming more dense. Travels all along the ocean floor, past Australia, up into the Pacific Ocean where it starts to heat up, and then travels through the oceans back into the Atlantic where it sinks back down. This is the overall theme of ocean currents that we are finding. Now, there's a couple different types of ocean currents. A little bit more small ocean current, or less of a global ocean current, are surface currents. Surface currents are going to be caused by things like wind. And remember, wind is all caused by uneven heating of the Earth's surface. Where the sunlight hits the Earth at more of a 90-degree angle, it's going to receive direct sunlight and make certain regions warmer than other regions that get less direct sunlight. So this is leading to our winds, and these winds will blow on the surface and will cause things like waves to take place. Now, depending on the season, depending on the time of day, these surface currents can change. Surface currents, but overall, the arching theme that we're seeing is along the equator. The colorful part, by the way, is the water. The gray part are the continents. Along the equator is where it's going to be receiving the most direct sunlight. And towards the poles, it's going to be receiving less direct sunlight. So we have an uneven heating of the Earth's surface, leading to winds, leading to surface currents. We also have more of a global scale called deep ocean currents. Deep ocean currents affect below the surface where these waves are, just below that surface, all the way down to the bottom and the depths of the ocean. Now, what causes these currents is something called convection, which we have talked about numerous times in the past. In this method, the more dense water is going to sink, the less dense water is going to rise. As the more dense water sinks, more water will flow in to replace that sinking water. So looking up here, this would be representing where we'll say the North Pole is. This is representing, we'll say, where the equator is. Where the North Pole would be, we have the warm water from the surface currents getting replaced by colder, denser water that will sink down. As it sinks down, it pulls the other warm water from the equator into it. This cold water will move along the ocean depths from the poles to the equator. At the equator, where it starts heating up because of uneven heating of the Earth, rises up, becomes less dense, and we have our convection current causing our deep ocean currents. Now, even though these ocean currents would like to travel in perfect straight lines, we have a few problems that are causing them to turn and not travel through straight lines. One thing that is causing a turning of the ocean currents is called the Coriolis effect. We've heard about the Coriolis effect before when we studied winds and global wind patterns. Well, this Coriolis effect also affects ocean currents. Water cannot flow in a straight line, all because of Earth's rotation. Earth's rotation causes the northern hemisphere, the currents in the northern hemisphere, to curve to the right, just like global winds, and it causes the ocean currents in the southern hemisphere to curve to the left. Another thing that gets in the way of ocean currents and keeps them from traveling in a straight line is not just the Coriolis effect, but also something known as continental deflection. Those pesky continents will get in the way of these ocean currents and cause those currents to get blocked from their intended path. Because they can't travel through the continents, they have to reflect off and bounce around, and that will cause things like the Gulf Stream in the Atlantic Ocean. Now, ocean currents can affect Earth's climates. If you remember, climate are weather patterns over long periods of time. These are climate is different from weather. Remember, weather was simply day-to-day atmospheric conditions. Is it warm out today? Is it cold? Is it rainy? Is it sunny? But climate is looking at long ranges of time. We can track climate over long periods of time, and we'll see differences from year to year, but we'll see an overall arching theme, as opposed to simply looking at the weather each day. So how do ocean currents affect climate? Well, we'll take a look at a couple examples. First of all, looking in Cornwall, England versus Newfoundland in Canada. Both of these locations are found along 50 degrees north latitude. This picture is a picture taken in Cornwall, England, and this is a picture taken in Newfoundland, Canada. Cornwall, England tends to have a much warmer climate. Here is Cornwall, the red star. This is where it's found. And here's Newfoundland in Canada, both of them at 50 degrees north latitude. But that Gulf Stream, because of the warm ocean currents being brought across the Atlantic to England and Cornwall, causes the climate of Cornwall to be much more mild and a lot warmer. Warm currents will bring warmer climates. In Newfoundland and Canada, where the blue star is, we have colder currents. These colder currents are going to bring colder climates. Ocean currents can also affect climate in that if we are along the coastal regions, like over here in Trenton, New Jersey, versus inland regions, like over here in Iowa City, Iowa. In Trenton, New Jersey, their average temperatures range from about 80 degrees to about 40 degrees. Whereas Iowa City, on the other hand, their highs average about 90 degrees and their lows average at about 5 degrees. Going from high to low in Iowa City is much more drastic than going from highs to lows in Trenton, New Jersey. Coastal regions are typically more mild in their climate. They have smaller temperature ranges. Inland regions are more wild. They have bigger temperature ranges. Kind of like roller coasters. They will have their highs and their lows. But coastal regions are like the kiddie roller coasters, where they don't have major highs and lows. They are mild. Inlands are wild, more like the Wild Thing at Valley Fair. They have much bigger highs and lows. So now it's time to go to your Google Forms and fill out your note summary sheet. Answering these three questions. Number one, what causes surface ocean currents and what causes deep ocean currents? Number two, how do the Coriolis effect and continental deflection change ocean currents? And number three, how are coastal climates different from inland climates? Have a wonderful day, kids.